Hi all, welcome you all to my YouTube channel. From this video, I am going to talk about simple linear regression with Hubble's constant story using Bayesian models. First of all, let's look at what is Hubble constant. The Hubble constant is a unit that describes how fast the universe is expanding at different distances from a particular point in space. It is one of the keystones in our understanding of the universe's evolution, and researchers are mired in a debate over its true value. In 1929, it was estimated as approximately 500 km per second per megaparsec. The present value of Hubble constant is approximately 75 km per second per megaparsec. Surprise! The Hubble constant changes over time. The reason we call it the Hubble constant is because the universe expands at the same rate at every location in the universe. The Hubble constant is constant throughout space, but the expansion rate and therefore the value of Hubble constant changes with time. Why is Hubble's constant important? The Hubble constant is one of the most important numbers in cosmology because it is needed to estimate the size and the age of the universe. This long-sought number indicates the rate at which the universe is expanding from the primordial Big Bang. Let's look at how the data behind this story appears. This data refers to the distance in megaparsecs of 24 galaxies from Earth and the velocity with which they appear to be moving away from us. Do you know 1 parsec equals to 3.6 light years? They were collected by Edwin Hubble in 1929 during his attempt to explain the past and predict the future behavior of the universe. So as you can see in this slide, Hubble formulated the following law. So that is the recession velocity equals to h naught times distance. So here h naught is the Hubble constant. There are two models in simple linear regression, such as with intercept and without intercept, or with constant and without constant. According to the Hubble's law, we should have the model without intercept or without constant. So let's try to fit a simple regression model to identify whether the constant or intercept can be set equal to 0 according to this data. So fit the simple linear regression model, we use the Bayesian analysis with the WinBUGS. So let's go to the WinBUGS code. So this is the WinBUGS code for model with constant. According to the figure 1, so we can have the output. So then we can fit the model as expected recession velocity equals negative 36.2 plus 448.8 times distance. Here negative 36.2 is the intercept of constant of the model and 448.8 is the slope of the model. Let's look at the confidence interval with 95% confidence level. Here beta naught, that is the constant, is in between positive and negative values. So then we can have the conclusion like 0 lies in 95% confidence interval for beta naught, that is constant. Therefore, we can conclude that beta naught is not significantly different from 0 until 0.05 significance level for this data. Let's look at how the data behave for the model without intercept. Let's look at WinBUGS code for fitting the simple linear regression model without intercept. This is the WinBUGS code for model without intercept. According to the figure 2, we can see the output of the fitted model. So let's look at the fitted model. That is, expected recession velocity equals 423 times distance. Here 423 is the slope of the model. Let's look at the confidence interval for the slope under the 95% confidence level. So we can see that 0 doesn't lie in this confidence interval. So we can say that slope of the model is significant. So this model is significant for the Hubble's data in the 1929. For the present data, we can have the Hubble constant as 75. For the 1929 data, we can have the Hubble constant as 423. So that is approximately equal to 500. Finally, what is the conclusion from this video? Finally, we can conclude that the model without constant is significant for the Hubble's data. Therefore, Hubble's law satisfied for the 1929 data. Thank you for watching my video. If you really like my video, don't forget to hit a like. Also, please don't forget to subscribe my channel and click bell icon to know about my upcoming videos.